Welcome back to our third Vodcast. Hello again, Odessa.
Hello, Rai. Good day, everyone. We are back again for our third podcast. This time, we are going to talk about space-time continuum and black holes. I kind of like to talk about these stuff.
I'm not telling you all that she's interested to sci-fi movies.
I'm not gonna also tell you that you already did it right.
Oh, did I? Well, anyway, since you're too excited and it's not obvious, don't worry. Can we hear some thoughts from you about your understanding about these topics?
Of course. Well, have you watched the Interstellar movie or Star Trek? There are certain parts in those two movies that tackles about black holes and space-time. In the movies Interstellar, they represented time as a physical dimension, and Cooper, the lead male in that movie, survived from being sucked into the black hole. It can be seen also in the movie that the light bends in space due to the gravitational pull in that certain region which we call as black hole. While in the Star Trek, the movie is more likely a venture to discover new things in space with their spaceship that jumps or travels in space and time. Well, enough with the movie reviews. So going back, space-time continuum, it is a four-dimensional continuum comprising with three spatial coordinates, namely length, width, and height, which basically things that conform with space, and one temporal coordinate or the time, where physical reality exists. This is a perspective developed by Hermann Minkowski to support and coincide with Einstein's special and general theory of relativity. I understood that it is termed as continuum because Einstein concluded that space and time are interwoven that spans multiple dimensions, and an idea known to those who have interest in physics would probably know that representation of space-time continuum is a space of fabric when massive object is placed in the center of the fabric that creates a distortion or curvature. The curvature or distortion depends on how massive the object is, and this curvature or distortion in space-time continuum is identified as gravity. This means to say that the deeper the curve, the massive the object is, and the stronger is its gravity. For instance, the black holes. Black holes are formed after the death of supergiant stars, and there are also supermassive black holes that lies at the center of a large galaxy, which is believed by the scientists that were made at the same time as the galaxy they are in. Black holes suck everything, even light, because its gravity is so strong. And black holes are predicted in the general theory of relativity, which states that matter warps the fabric of space and time. This means to say that black hole, since it is made of very dense accumulation of matter, warps space and time.
I told you, it's not too obvious. Anyway, thank you for that, Odessa. Surely, our viewers have learned a lot, and I guess Google's and our YouTube search bar popular search word for today is Interstellar's full movie. Well, anyway, as what we are always saying here, we have different ways of understanding modern physics topics, and I know not just on this subject. Just like Odessa, she relates it into a movie. In my case, my understanding about this topic, general theory of relativity, is that it is a major building blocks of modern physics, as it explains gravity based on the way space can curve, or to put it more accurately, it associates the force of gravity with the changing geometry of space-time. In short, it is a theory of gravity. The basic idea is that instead of being an invisible force that attracts objects to one another, gravity is curving or wrapping of space, which is also mentioned by Odessa. So here, the more massive an object, the more it wraps the space around it. For instance, the sun is massive enough to wrap space across our solar system. A bit like the way a heavy ball resting on a rubber sheet wraps the sheet. As a result, Earth and other planets move in curved paths or orbit the sun.
Thank you, Rai, and thank you everyone for watching and being with us since the first podcast. I hope you also gained new knowledge from us, just like what we gained from each other.
Never stop learning. Thank you and have a good day, everyone.